Last section on the notes is verifying a right triangle. Theorems work in two directions, so we can use the Pythagorean theorem to determine if a triangle is a right triangle. Three whole numbers that satisfy the Pythagorean theorem are also known as a Pythagorean triple. So before we look at these new examples, let's look back at the things that we've already done. So if we flip back a page, it says when we're solving for a missing leg, on this first one, we know that this is a right triangle because it's got that right angle drawn in, and my Pythagorean triple potentially could be the numbers 12, 7.21, and 14. It satisfies the theorem, but because the 7.21 is a decimal, they're not considered triples. If we look at example 2, we have 8, my side 15 that we found, and 17. That makes it a right triangle, and it's a triple because this 15 is a whole number. So example 3, we know that it's a right triangle because it's given, but my three numbers aren't a triple because that hypotenuse was a decimal. 4 was a Pythagorean triple because the hypotenuse was a whole number and the legs were also whole numbers. So, in example 7, we want to make sure to identify the potential hypotenuse. The hypotenuse is always the largest, so this could be our hypotenuse 17, and we'll put a question mark because we don't know for sure yet. We'll see if 5 squared plus 12 squared equals 17 squared, and I'm going to put a circle because I don't know if it's equal or not. So 5 squared plus 12 squared, 169. If you had to guess, does 17 squared equal 169? It does not. So they are not equal, which means this triangle is not a right triangle. In example 8, the hypotenuse is always the biggest. So 12, 16, 20. 20 is the biggest, so this could potentially be my hypotenuse. Using the theorem, we'll say 12 squared plus 16 squared. Does it equal 20 squared? I don't know. Let's check. 12 squared plus 16 squared is 400. Is 20 squared 400? Yes. So we would say it is a right triangle. So I guess we need to go back and say no, yes. All right, last section. Fill in each missing blank, then determine if the sides make a Pythagorean triple. Example 9, we are given A, B, and C in the columns, and we know that the Pythagorean theorem is A squared plus B squared equals C squared. And so we will kind of off to the side, 7 squared plus something equals 18 squared. We're looking for whole numbers. And so we have our 7 squared, which is 49, and 18 squared, 324. We're going to take away the 7 squared. We get 275, so b squared is going to be 275, and we're going to take the square root, 16.5. So we've created a right triangle, but is it a Pythagorean triple? No, because this is a decimal. Example 10, we've got 3, 4, we've got a leg, so we've got leg squared, 3 squared plus 4 squared equals our potential hypotenuse. 3 squared plus 4 squared is 25. Is 25 a perfect square? It sure is, so C would be 5, which means that we do have a Pythagorean triple. This 3, 4, 5 is one of the most common Pythagorean triples that you'll see, and it's multiples. So 3, 4, 5, if we double it, 6, 8, 10. If we triple it, 9, 12, 15. Any variation without doing any math, if you have those memorized, you can already state, hey, yes, this is a right triangle. And then lastly, we've got a squared plus 18 squared equals 32 squared. So we'll kind of solve it from here. So we'll start with our 32 squared. We want to get rid of the 18 squared, so we cancel it out by subtracting. And we've got 700. That's a nice pretty number, but is it a perfect square? It is not, which means that we do not have a Pythagorean triple.